In this video, let's look at amplitude and period. So far, we have studied sine of x and cosine of x with fundamental period of 2 pi. There are four parameters that we want to look at. They're labeled A, B, C, and D. And so you see the functions and you see what these parameters represent. Let's look at amplitude first. It's a vertical stretch or shrink. The constant factor A acts as a scaling factor. When A is greater than 1, the curve is stretched vertically. When it's less than 1, it is shrunk vertically. So the range of the function for A greater than 0 is minus A less than or equal to Y less than or equal to A. Here's an example of three of them. Let's get the definition of the amplitude of sine and cosine. The amplitude of y equal to a sine of x, and that should be y equals a cosine of x, represents half the distance between the maximum and minimum values. What happens when a is less than 0? We have a reflection over the x-axis. All right, let's try some graphing. Suppose we want to graph y equals the sine of x in yellow, 1 period of each, 3 sine of x. Notice the amplitude will now be 3. We'll do that in blue. Y equals 2 cosine of x is sort of in a purple. And then y equals minus 2 cosine of x is sort of in a peachy color. Hopefully you can see the difference between them there. It took me a few minutes when I was trying to draw these. I'm not very good. We've looked at the vertical stretch and shrink. Next is the horizontal stretch shrink. Now consider the impact of B on the graph. You see where B is in the equations. So we're going to be looking at period, which is horizontal stretch or shrink. The constant factor B allows the period of the function to be changed. Fundamental period, remember, of sine and cosine is 2 pi. Sometimes applications that use these functions need more often or less often than 2 pi. So, when b is greater than 1, the period decreases and the curve shrinks horizontally. This seems almost like a contradiction, right? But we're going to go on. When b is between 0 and 1, the period increases and the curve is stretched horizontally. When b is less than 0, then sine of minus x equals minus sine of x, and cosine of minus x equals the cosine. So the period then for a function is always formed by 2 pi over b. Here are some examples to look at. Cosine x and cosine of 2x. Right. We're going to try some of these graphing. So here we go. Let's graph y equals the sine of x, and we know the points we need to look at. And here the sine of 2x has a period of pi, so you see it's only half the size of the sine of x which we worked on. Okay, well, let's do similarly for the cosine, only in this case we're going to stretch the cosine because 2 pi divided by a half is 4 pi. So now we've stretched the cosine curve to going between 0 and 4 pi. And so you see how we draw it here.